Solving inequalities. Grade 11, pretty common, good times. So inequalities, mathematical statements that relates to two unequal expressions to each other. Inequalities have many solutions. So it's not just x equals 2, maybe x is greater than 2, and there's a bunch of solutions, right? 2.5, 3, 9, 10, all of those are included. So integral notation versus set notation. I think I go to integral notation more. That would be the one that I would in. More people like this more. For some reason, the greater than less than signs for everybody else and in the direction, and it's hard to read, but you still need to be able to do that. Just, you know, x is less than b, so we know that whatever b is our number. There's no equal sign, so it's a round bracket. If there's an equal sign, it's a square bracket. Infinities, always round brackets. Grade 11, you got it. Easy peasy. So let's graph it and do some wonderful integral notation, set notation. Okay, so what's the set notation on this right here, on this integral? -5. Here's the thing. Put the variable in between. All the signs will be, all the alligator, the big mouth of the alligator will be pointing towards the left-hand side of the set. It up this way. So x has to be greater than or equal to, I know it's equal to because there's a square bracket here, but less than +3. Now we're going to draw a pretty graph. Because they only have one variable, it's going to be a line graph. -5, 3, closed circle at +5, open circle at +3, and then a line connecting those, because you're saying that the values are in between those two numbers. The next one, set notation. X has to be greater than or equal to 4. Put it back into integral notation. Yeah. Inclusive or non-inclusive of 4? Inclusive, so a square bracket, round bracket. If I were to do this wonderful chart, +4, closed circle, and then I'm going to have an arrow indicating that it's going to continue on forever and ever. They're exactly the same, yeah. All right, so let's just fill it in for funsies, just so you have a complete chart. Do you guys use Z or I for integers? Z. These are you use Z. You're all Thompson. You've all been converted. All right, this one. So this is saying it's got 2 parts to it. What is it saying? So it's kind of a strict question in set notation. It includes 2, and it goes from negative infinity to positive infinity. So in set notation, I just simply write this. That's every number. I'm not 100% sure what I'm going to break in it. It usually indicates, like usually round brackets around here. That would mean that it doesn't include 2, but sometimes square brackets. So when I'm doing my number line, it doesn't really matter what values I put on it. I would just have a line that goes forever and ever on the other side. But what kind of break is inclusive? Oh, a break in the graph, yeah. So it's not a continuous graph. Good point. Good point. All right, determine which of the following numbers is included in this interval. Is -6 included? No. Because it's less than -5. Is -5 included? Yes, because it's a square bracket. This is a great Friday lesson. It's really hard. It's like an 8, maybe 11 all over again. You're going to get time to work on your problem set that you all finished, right? 1. Is x equal to 1? Is that included? Yes. X equal to 3? No. No, because it's a round bracket. What about 4? No, because you've blown up the other side of the interval. Oh, no, it's so hard. I almost think this is a better lesson for grade 11 inequalities. My calculus lesson is better than my grade 11 lesson on inequalities. Let's solve the inequality. X is to one side, constants to the other. The trick here is let's say I brought the 6 to this side. So I have -5x is less than -5. Right? Let's just say I did it that way. If I divide by a negative coefficient, what effect does that have on the inequality? Switches it, you guys remember that? So if I did it the other way, so now I've got +5 is less than 5x, divide by +5, divide by +5. The inequality doesn't switch when it's a positive. And if you look, even though they're written differently, the big nose of the alligator is pointing towards the x on both of them. Okay? So it doesn't matter how you do it, when you're dividing by a negative coefficient, you have to remember to flip your inequality. All right, solve the inequality here. Simple factoring question. Oh, so nice. Remember this is a grade 10. Factoring. Factors of -12 that add to -4. Anybody? I love it. That's supposed to be a 6. We'll just make a 0 with 6. Now we're going to write that as an inequality. Or how are we going to put that in set notation? Okay, so I know on my number line I'm going to have two numbers, right? I'm going to have a +6 and a -2. Are they going to be open circle or closed circle? Open, because there's no equal sign. And now I'm going to figure out, am I going in between those two dots or away from those two dots? So pick some test points. What would be a great test point to pick? 0. I love it. So if I substitute 0 in here, -12 is less than 0. Is that a true statement? So my solution lies in between these two dots. I find it easier to do my number line first, then I can do my next time one. Set notation. All right, let's do set notation. Lower limit, -2. Upper limit, +6. X goes in between. Fancy brackets. Where X is an element of the real numbers. Hard. Super hard. me to do my number line, what numbers am I going to put on my number line? Hint, hint, I'm going to have 3 of them. Positive 1, positive 2, positive 1, negative 3. Close or open circles at those points. Close because I have the equal sign this time. Okay, now I just got to figure out how I'm connecting the dots. So I'm going to pick a value between 1 and negative 3. Good. We pick an easy one. So if I substitute 0 in everywhere I see x, negative 1 times by positive 3 is negative 3. 6 is greater than 0, so it's true. So these two are going to be connected. Now I'm going to pick a value in between 1 and 2. 1.5. Okay. I'm not actually going to do math. I'm going to do positive negatives because it's Friday and I'm living on the edge. So if I substitute a negative 1.5 in here, would this term be, or I guess not term, would this factor be positive or negative? Again, if I substitute in a positive 1.5 in here, positive. If I substitute in a 1.5 in here, positive. If I substitute a 1.5 in here, and that has to be greater than or equal to 0. Positive, positive, negative. What's that going to give me? Negative. Is a negative number greater than 0? Is it equal to 0? So I know that this is not a true statement in here, so my line would extend it here. If you want to double check, do it for 3. X is equal to 3. If I put 3 in here, it's positive. 3 in here is positive. 3 in here is positive. Positive would be greater than 0. Does that make sense? I don't really have to do any math. I just have to be able to reason it out. Okay, so that's my solution. Now I got to put it in set notation. So you're going to have 2 different sets. You've got 2 different things happening. So I'm going to have from negative 3 to positive 1, x in between, x has to be greater than or equal to, on both of those, in unison with x being greater than or equal to positive 2, fancy brackets, x is an element of the real numbers. This is a great Friday lesson. I kind of want to keep going, but I think you guys might vote me off the island. So that's today, grade 11 in your calculus class.